yesterday, at the last session, we looked at housing finance and post-COVID era products, innovations, and options. And there are two key players that were meant to present papers that, because of the exigencies of the duty, they were unable to be present. We are going to be merging them with this technical session. And of course, you know that when you talk about innovation, you're talking about transforming the construction sector, you need finance. So we are bringing them in to join in this technical session this morning. So on that note, you will permit me to invite the chairman of the technical session this morning, Professor Charles Yangete, the chairman of Innovative Risk and Investment Solution Limited, as the chairman of the technical session. Please, let's put our hands together as he comes. Please join me to invite my colleagues to introduce the other speakers for this morning presentation.
Very distinguished ladies and gentlemen, once again, welcome. I especially welcome you to day 2 of the largest, the biggest, and if you like, the most profound housing and construction sector stakeholders forum in Africa. If you are excited to be here, please, a round of applause for yourself and for the brain behind this gathering. I want to recognize the presence of the Honorable Minister of State, Ministry of Works and Housing, Ghana, Frida Prempe. Once again, we celebrate you, madam. Thanks for being here. Well, like my colleague said, we will be bringing speakers for the Lafarge session, Construction Technology, Transforming the Construction Sector, Utilizing 3D Technology, the Lafarge Experience in Africa. Please, ladies and gentlemen, help me welcome Professor Brando Okolo, Founding Director, Germany-based Stern-based Institute for Material Application and 3D Printing Solutions. Please, a round of applause for him as he makes his way to the podium. Also help me welcome Babajide Odusulu, MD CEO, Octo 5 Real Estate. We also have as our speaker, Engineer Jumoke Adegunle, Head Motor Operations, Lafarge. A round of applause for her, please. Engineer Femi Yusuf, Head Product Technical and Innovation, Lafarge. Please, we can do better than that. We can do better than that. Like my colleague said, yesterday, we're supposed to have the MD, Federal Mortgage Bank of Nigeria, in the housing finance in the post-COVID era. He was supposed to speak yesterday, but he was not present, so he will be joining them this morning. Please help me welcome Mr. Ahmed Dangiwa, MD, Federal Mortgage Bank of Nigeria. A round of applause for him, please. Femi Adewale, Managing Director, Family Homes Fund. Please, a round of applause for him. I'm sure he'll be here any moment from now. Distinguished ladies and gentlemen, I will be handing over to the chairman, Professor Charles Yangete, the chairman, Innovative Risk and Investment Solutions, IRIS Limited. Mr. Chairman, sir.
Thank you. Good morning, everyone. I'll stand on the existing protocol because I know we're really pushed for time. It's my pleasure and delight to welcome you to this particular session on construction technology, 3Ds, and the rest of it. The construction technology, construction materials, techniques, as well as technologies to build net zero buildings is critical for moving forward. If we want to have buildings that are ready for the future, we need to ensure that these buildings are sustainable in terms of their impact on the environment. We want to ensure that these buildings are able to be people-centric, in other words, respond to the needs of the occupants. We want to ensure that these buildings are able to be hyper-efficient, which means for maximum performance, we're minimizing the costs. And we also need to ensure that these buildings are able to really be resilient and adapt and respond rapidly to the changing environment. And so without further ado, I invite our first and key speaker for this session, and that is Benga. Why are you not up here? Yeah? Sorry that you were not introduced. My apologies on behalf of the... Can you sit on this side? Because you're speaking. Use the podium. I invite Mr. Benga Onimo, who is the commercial director at Lafarge Africa. Please take the podium. Yeah. You have just 10.5 minutes to present.
With the media team, please, can you help project this? Thank you very much. Good morning, everyone. I'll be standing on the existing protocol. Again, we from Lafarge Africa PLC, a member of the OSIM group. I know a lot of people know us as Lafarge OSIM, but very recently we changed our name, rebranded. We're now OSIM as the group point of view. We're talking housing. I mean, very interesting conversations we've had in day one. And I think when we look at all of this, the big thing that comes around is that, yes, there's need for housing. Can you go to the next slide, please? We all agree. I mean, the world is changing, population is increasing. There's definitely more need, more demand for housing, and it will continue. You know, that deficit we talk about will continue to widen. Regardless of what we put in numbers, I think the common point is there is need for more housing, right? And again, if we look at the way we build today, it's also a concern. I mean, it served us, yes, it's taken us to where we are today, but of course, looking at where we're going, we need to move faster. We need to do more. And it doesn't just come easy. So it means we need to find ways of building faster. We need to find ways of building more cost effectively. Yesterday, we talked a lot about financial products, to support this vision. But, I mean, the pocket is not endless. So we definitely need to ensure the methodology of building also can be more efficient, more cost effective, find a way to take out really, waste in the whole process. And I think that's very important. And that's where for us, when we look at the way we build today, you say, there's not been so much innovation. It's been really very traditional, same for a long time. I mean, we all know it's brick and mortar most of the time, and again, it takes its time, the process and all of that. And if we look at it, the cost of materials that we use for all of this, it's a lot. Apart from the cost, there's multiple materials, and which requires a lot of people, labor also. So sometimes, when we were talking yesterday, I was listening and trying to imagine, to say, when you actually look at the cost drivers, apart from the land, when you look at cost drivers in putting up affordable building, A lot will be around materials and labor. So really, if we have the right technology that can address this, it's going to help. Yes, we need the speed because we have a long way to go. I think I recall yesterday when His Excellency, the Minister from Ghana, mentioned the number from Shelter Afrique in terms of the deficit. I think she was talking about 56 million just among 44 countries in Africa. 56 million, that's massive. You're wondering how long it's going to take us to build. So it means we need to build faster. The current way of building today probably won't help us to get there. And again, it's also very important. I mean, our theme is talking resilience. So sustainability is also very important too. The carbon footprint, we want to go greener, climatic, we all talk about climate change and all of that. So how do we ensure also the technology for building also helps in that perspective? These are concerns for us also from a Lafarge point of view, which makes it very important to think around the technology that can address this. So for us, really, we think we need to start, building new generation houses. Some of us will say, oh, are you sure of this? But the fact is that there are challenges in the world today, and we need to start building better, more affordable, more eco-friendly. We need to go green and cost efficient. And of course, it needs to also match the timelines. Yeah, the next slide, please. So I'd like to show very quick, the video. Hello, media man, can you go back? Yes, can you click the video, please? So for us today, thank you very much. So our focus today is on the 3D technology for construction. That's really what we want to focus on today. So for us, there's a need for a change on what we do today. And what's 3D printing, really? It's simple. It's simple printing. Basically, sequential layering of materials. You just you saw the machine, keeps going on, laying up the materials till you build. And that's what it is. Specifically for housing, it's about building the walls of the building, the walls of the house. That's what the 3D print will do. It builds that, keeps laying up the material, and you build the walls very quickly, both internal, external, and very fast, very fast. Within a few hours, you can actually put the walls of a building. In Malawi, for example, the school was done in 18 hours. A school on a 56 square meter was done in 18 hours. The entire walls were built already. So that's really what it is. It's as simple. It's as simple. And we already in Lafarge are already aligned in this technology. Someone will say, oh, this is digital. Are you guys sure about this? Yes. I can show you, you'll see in the next video, classrooms, children are already in there learning. So it's real, it's live. And for us, when you look at the benefits of this, right, like I said earlier, we'd agree that material costs is an issue. I mean, you and I know today when you're building, yes, they tell you this is the amount of material with your BOQ and co. But managing the materials, there's a lot of waste, there's a lot of loss, that happens at site through materials. But with 3D printing, you don't need to be bringing materials to the site. You're just going to load up materials that you need exactly. It's in the machine. So no one is going to, shortchange you. And from what we've seen so far, about 60% savings, actually, you can make on materials. 60%. Productivity is also, like I mentioned, speed. 18 hours building the walls of a school. Once you put the framework, the walls, then you're ready to go. Flexibility and scalability that this can also give you. Your shapes, the size, different things you can do. You can manage it in different ways and create some aesthetics leveraging on this. So it can be customized also to what you want, and that's the beauty of the 3D print. Logistics, when we talk about construction, can also be a challenge and a cost driver. And that's one of the things that this helps. With 3D printing, you can cut off a lot of unnecessary costs. And this is where you make the savings. So you're getting speed, you're making savings, and of course, it's also, we're talking green. Next slide, please. Simple process. Sorry, you move too fast, Mr. Can you go back, please? Go back, please. Go back. Back. You're moving too fast. Yes, sorry, that's it. So 70% time from what we've seen that you can gain, 70% savings on time. Okay, next. And for us in Lafarge, next slide. For us in Lafarge, we're not on this alone. So the approach is really, bringing all stakeholders together. We're not working alone on this. Contractors, developers, design offices, printing companies that would make the printers, because you have different sizes, different printers you need for depending on the material you want to use. And of course, with the academic body, research a lot. We actually invest a lot in research. We have a huge R&D office in France that we leverage on, that's been working on this. So again, that's the way we've started the process. The next slide. And we've gone through the different stages. For every project that we've tried to test this on, first is looking what's the product, the design, the print technology, and the material you want to use. The next, so this is just telling you that, you could think, oh, 3D, next slide, 3D print, in some place, would you need to use reinforcement? Yes, there can still be some reinforcement. Can you go to the next? I'm trying to move very quickly because I can see I'm being notched already on time. So with respect to the material, the ink that's actually using to print, we have the technology in-house. We're making that also in-house. We are, of course, we are strong with building solutions, cement, dry mortar. So all of these technologies are also what is necessary for this. So we already have that. We're experts in that already. And the different mixed material that you can actually use. So examples of structures that actually we've worked on. Can you go to the next slide quickly? If you can click on that video, go to the next slide. Yes, just click on the video. So that's, you see the school I was talking about in Malawi. And with pupils already in there, you can see the walls, you can appreciate it actually. Fantastic, that's the school, Sitting on 56 square meter, very quickly done. And for them in Malawi, when they look at the deficit they have in terms of schools, they wanted to focus in that area to close 36,000 schools that backlog they have. And this actually is a way to go. So we're actually leading that. If you go to the next slide, please. Yes. And also a 2-bedroom house done already with the family moved in. I think this was actually sponsored by Habitat for Humanity. And again, you can see some designs from Iraq. So we're working across Africa. There's several projects actually that we're on this. And this is just to give you also a feel. Next slide. On some of the big projects doing turbines, you can actually go high. So again, question is around, can we go multiple floors? Yes, we can. But we've seen that in some other countries. In Nigeria, we want to start stage by stage. And I think when we look at the needs we need to address, actually, you actually want to start from ground floor. So this is a footbridge that will be used for the Olympic Games in 2024. And Lafarge already has the right to actually, build this there. So this already work is going on and will be live. And if you look at the next slide, please. So again, this is another bridge, footbridge. Can you click on that video? A footbridge that Lafarge also had worked with other partners, companies to actually bring to life also. And this was this is in Venice, in Italy. This was opened just in July the 19th, precisely, that this was actually opened.
No glues, no binders. It uses the minimal amount of material for maximum strength. 3D printing opens up a world of possibilities, all the way from complex infrastructure projects to affordable housing. We can reduce up to 70% of materials with no compromise on performance. That is a breakthrough from a sustainability perspective. And that, for me, is building progress.
Next slide. So for us, it's impressive. We're quite happy. This is just showing you different ways of getting people into the 3D thing. So we create competition among students in various universities. Can you go to the next slide? And for Nigeria, our approach is we're building a 2-bed project, hospital project as a CSR, somewhere in Shagam with 3D. And this, once it lands, next slide. So in terms of technology, in terms of resource, we have it. And we're working with a company, a sister company of Lafarge, based in Kenya, that will be using across to run this in the entire Africa. Thank you very much. Sorry, Mr. Chairman. Thanks. I know the time was not enough, but I think we can talk more during the time.
Thank you, Banga. I'm not going to take time in commenting on what is said. I'll leave time at the end for that. The next speaker is Professor Brando Okolo. He's the founding director, Germany-based Steinberg's Institute for Materials Application and 3D Printing. Professor, you have 10 minutes.
Okay, thank you very much. Yeah, thank you very much for the opportunity to talk on this forum on a very interesting topic, 3D printing technologies. It's a technology that's been in the works for the past 35 years. And we've seen it grow from being a rapid prototyping tool to now being a construction tool. And beyond the current topic of buildings, you can also use 3D printing technologies to essentially build all kinds of machine tools, consumer products, and interface with all kinds of industries. Okay. Next slide, please. So for my presentation today, I will first of all try and give an overview of what 3D printing is and why you should use this technology within the construction industry. I'll talk about 3D construction printing today and in the future, and I'll give a few final remarks. Next slide, please. So what is 3D printing? Luckily, the speaker that spoke before me, he's already given an insight into what this technology is all about. So imagine you have an extrusion machine, a machine that allows you put down material in a layer-by-layer fashion until a three-dimensional structure is built up. That's essentially what the machine is all about. But the first thing, of course, is that you need to come up with the product you want to design, or what you want to fabricate, whether it's a house, an engineering part, whatever it is. The starting point for that process is in the design. So you need to be able to use design tools to produce what you want to fabricate. Next slide, please. So I'll quickly give an overview of what 3D printing, or how the process of 3D printing goes. Can you go back, please, if you don't mind? Yeah, exactly. So imagine you have the sculpture. There are two ways you can actually produce this sculpture. First is by taking a block of, can you click on the, yeah. First is by taking a block of stone and chiseling out everything on that stone that doesn't look like the sculpture. Next slide, please. The second is by having a free surface on which you start putting materials together until a three-dimensional structure is built. So in both cases, in the field of manufacturing, the first example is called subtractive manufacturing, where you have a big block, you chisel out everything or chisel out material, and then you have your final product. The second is called additive manufacturing, and I'll come to that, why 3D printing is being scaled up to additive manufacturing. So additive manufacturing involves putting materials together in whatever form, either in the form of pottery work, in the form of casting, and of course also in the form of 3D printing. So the word 3D printing is today used generic to describe the technology, but strictly speaking, this is called additive manufacturing. So what you find in engineering textbooks, what you find in textbooks that are used in the academic world is additive manufacturing. Next slide, please. And so today, essentially all existing engineering material or technical materials can be 3D printed or additive manufactured. So you can 3D print paper, glasses, ceramics, polymers of all forms, metals, concrete as we have it today, and all kinds of other composite materials. Those today can be 3D printing, including concrete as we know it. Next slide, please. So what does a 3D printing workflow look like? As I already mentioned, you start off with a design, and that design can be generated either using your computer-aided design tool, or you could use a 3D scanner to generate that design. Now, the data you generate from that is then prepared for the printing process. So the preparation is simply a transformation of your data format from one form to a machine-readable format. Next slide, please. And the machine-readable format then allows you, that data allows you print or lay down materials in a layer-by-layer fashion until your three-dimensional structure is formed. And so you see a system that allows you build structure, build it fast. If you could scale beyond that point of just building one structure and building fast, you can go into a point where you're building several and building fast. So imagine this industry, this very conservative construction industry, becoming a mass production line. This is what we're looking at. We're looking at a case where you can actually take this technology, not just build one, but build several in a very intelligent way. Next slide, please. And so the key components that makes this, the use of this technology advantageous are speed. Speed is important. Speed allows you as an investor put your money down and as quickly as possible reap that revenue or reap the return on investment as quickly as possible. The less use of materials, because only the amount of material that is precisely needed is what this machine will lay down. And of course, less labor. I've had discussions with people here in Africa where we've looked at the labor significance of using this technology. So labor is very cheap in Africa, so it doesn't matter. But we have other aspects of labor that allows this technology come into play. The construction industry is a very muscle industry. It's an industry where the labor we need on site is muscle labor. So you get to a certain age where you're no longer required in the construction industry, even though you come with a lot of experience. So what this technology allows you to do is to transit from a position where you use a lot of muscle to where you use brain power to build. It also allows the female folk to come into the construction industry and perform. And of course, the ability to build relatively complex architectural works. This technology allows you to do that. It's eco-friendly, and of course, reduction in injuries that we find in the construction industry. In the construction industry, there's a lot of injuries, human injuries. You can significantly cut this down by bringing this technology on site. The good thing about it is that the amount of people you need on the construction site can significantly reduce. With this technology, you only need 3 people on your construction site. You need your CAD engineer who drives the machine. You need your materials engineer who ensures that the pumps that pump material from a silo or a reservoir to the print head is moving unobstructed, and you need a structural engineer to make sure that all the parts or all the materials that have been laid down as you build your building, that those materials conform to all kinds of engineering requirements. And so from a comparative point of view, where your savings mainly come from, when you look at the entire value chain within your construction field, land, permits, materials used in building of the superstructure, the fittings, the finishing, when you look at all these cost components and you insert this technology within your costing, the key areas where you see significant reductions are in material and in labor. And those reductions are significant. They really are. To the point where you can cut down, when you compare your conventional building, you can cut down by up to 50% in cost. That is a lot. And this is what this technology offers. Next slide, please. Now, when you look at the industry globally, as I said, it's still the technology is young, and so its use within the construction industry is also quite young. But we already have a space that is populated by all kinds of groups. Groups working on the machine manufacturing, groups working on the materials manufacturing like Lafarge, groups working on the software that is used in driving this technology on the construction site. So I've put up these companies to give you a sense of where they are, who they are, and which fields they are working on. There's still a lot of work to be done, and I think we'll get there at some point. Next slide, please. So globally, 3D printed houses exist essentially on all continents as we speak today. In Denmark, the company which Lafarge partners with, Cobod, they are the machine builders. We also have a partnership with them. They've built the first 3D printed house in Europe. We have houses now printed in Italy using earth, mud. We have houses in Russia, in Germany, of course. We have the first family-built 3D printed house existing in Germany. In France, in the USA. Next slide, please. In the USA, in Belgium, in India. Next slide, please. In China, in the UAE. Next slide, please. In Saudi Arabia and in Malawi, which is the first encounter this technology has had in the construction industry within our continent. The next slide, please. Next slide, please. Good. So what does this technology hold for us beyond today and beyond? Beyond today, what we can do with it is that the transformation we expect to find also in the construction industry could start. We already have software tools, the so-called BIM, the Building Information Management tool used in the construction industry that allows you have a complete overview of from the idea to the point where you actually have a finished product. You check on your cost, the amount of material used, the timing, the scheduling. This tool, the insertion of 3D printing technology within this tool will revolutionize that sector. It will allow you approach a client, say to the client, this is what I want to build. The client says to you, this is what I want to build. You interface with the client on a computer surface. The client is able to scale the land which they've bought to the architectural work. It allows the client to have all kinds of optical understanding of the architectural work they want to have built up, the simulation work, the time it would actually take to be able to build that structure, the amount of materials that are needed, the renderings, gives the client a completely new experience about the project work or the project work they're trying to build up with you. It allows the client to understand what's happening on site without being physically on site, and of course, it allows the client to have a first-hand understanding of what it will be like to have their own house. So this is where we are. We're at the point where the data that is generated from the architectural studio to the data that is generated on the construction site gives the client and that gives our economy a completely new experience. We've heard, for my conclusion, next slide, please. Next slide, please. Good. So we've heard that the affordable housing gap is widening and that bridging that gap is difficult. I don't want to debate over the numbers. Whatever the numbers are, we have a problem. We have an affordable housing gap, and that has to be bridged somehow. Using conventional manufacturing methods, we cannot easily bridge it. So we definitely need a technology that will come and speed up that process of bridging this up. In terms of cost, this technology would allow not just those in the middle income class, but also those in the low income class to be able to own their own building as well. So my appeal to you as a community deeply involved in the construction sector, bring this technology not just into the Nigerian construction world, but look at Africa. You are industrial heavyweights. Go beyond Nigeria. Adopt this technology and see yourselves do something unique for our continent. Thank you very much.
Thank you, Professor. We'll leave time for questions at the end of it.
Okay, thank you.
Take your seat. Thank you. Our next speaker is sitting right to my left, Mr. Babajide Odusholu. Yeah, it's you next. He's MD, CEO of Octo5 Real Estate.
Good morning, everybody. All protocols duly observed. Unlike the two gentlemen before me, I'm not selling 3D technology. I think I'm more coming from the user's perspective. And the first thing I just want to observe is this. Construction technology is of critical importance. We're all avoiding the big question of what is our actual demand gap. But I don't care whether you call it 17 million, or as the Honorable Minister from Ghana said, where they have 2 million, or you call it 2 million. It doesn't matter what you call it. The fact is we have a crisis. In Nigeria today, and my Oga, Reverend Chima is here, I doubt there's anybody who's building up to 100,000 houses a year, government included. The maximum production per year in Nigeria is not up to 100,000 homes. And whether you believe it or not, the real demand will keep growing because 50% of our population is under 21. They're going to grow up, they're going to have kids. They're going to want homes. So it doesn't matter what you think the actual number is, it is a crisis. Now, the only way you can fix a crisis is a quantum leap. You've got to find solutions that make it possible for you to transcend the gaps that you have. And in order to do that, one of the things I always avert my mind to is to dimension the actual real demand. Now, what is a real demand in Nigeria for homes? Every research that we've gone through right now points to the fact that 45% of the home demands in Nigeria are for mass affordable homes. And these are homes priced not higher than $10,000. Put it to each understand what I'm using for my dollar rate, I'm using 500 to 1. So the maximum price point for 50%, roughly 50% of the homes that we need in this country is 5 million naira. Okay? That's $10,000. The next large gap is the middle market, where the vast majority of the working professionals in Nigeria, and if you discount for underemployment, discount for unemployment, we're talking of roughly about 30 million Nigerians who are in paid employment or working for themselves. The average, the 40% of the demand for homes is for that class of people. Now, these people would buy homes priced between $12,000 to $50,000. You're talking 6 to 25 million naira. I'm talking affordable homes. Now, when I say affordable, I'm not talking social housing. I'm talking homes that they can afford to buy conveniently. And we're all practitioners here, and I'm glad to have my Oga, the MD of FMBN here also. They've got money. My other Oga, Femi Adewale, is also in the room. I call them my Ogas because they're the ones that dictate the tune. You know who pays the piper. You know, so they pay, and these are the prices. These are the houses that they want people to buy. Then the last category is where you have 15% of the demand, which are premium homes. These people don't care about the price, really. They just care about the quality. We're not talking about them here. So if I'm looking for solutions that will make it possible for me to take care of 85% of the market demand, then I've got to ask myself, what do I need to do? Now, incidentally, factor into that urbanization rate in Nigeria is 55%. It means everywhere is getting urbanized. And then with the increased security also, the urban centers are becoming more and more populated. So everywhere is getting choked up, and it is going to get more choked up. It is a fact of life. So it means that when you're building in the urban centers, you're not going to be doing sprawls. You're not doing bungalows. I'm sorry. You're going to have to scale up. You're going to have to go vertical. So it means any solution that you're putting in place has to be something that creates efficient, quality, vertical homes that are affordable. So you go to market with that kind of shopping list, then you then ask yourself, okay, what are the constraints that the market then gives you that makes it difficult to apply? Now, this is not a plug, but I commend Lafarge a whole lot because they've been very bullish on coming up with solutions in the industry. I've worked with them on the past, and I was really impressed with what they come here with 3D technology, because the last project I did with them, we used formwork to do homes, because we're trying to do 4-story homes. I wanted to do it so fast, and we're using formwork to do the homes. And that's when I realized that in the whole of the Southwest, there were only, this is crazy, there were only 4 concrete pumps. So if you're doing a 5-story building, you actually wait on a waiting list, because they can supply you concrete, but you can't pump the concrete because the pumps are not there. So that's when I realized that the problems we have, the peculiar problems that are in our society, in our environment, that you've got to fix before you can begin to come up with this great concept that we're talking about. And whatever you're coming up with has to be solutions that are also sustainable in the reality of the environment. Now, I'm going to have a lot of questions for the 2 gentlemen, Brando, right? And my brother here that spoke about 3D printing. The thing that kept on going in my head is power. If I'm going to deploy, I mean, Reverend Chima, you can agree with me. If I'm going to deploy these machines in Mamusa or in Kuje or on the outskirts of Lagos Ibadan Expressway, how much power do I need? How am I going to truck them there? How am I going to make sure that by the time they get there, the actual print heads are not broken? Then I've got to go back to Sweden and wait for customs to clear them, to bring it. There are peculiar issues that we're going to have to fix here to make sure that the solutions that we put in place are actually adaptable and scalable. Hydrofoam has been working in Nigeria for well over 15 years. They've not been able to scale. And the reason they've not been able to scale, one of the things I always tell people, people ask me, why don't you use hydrofoam? I say, because to use hydrofoam, I've got to have earth. I've got to have massive earth. And it's just not scalable. I'm sorry. I'm not trying to demarket any solution. It's just not scalable. I'm going to still have to do concrete. And if I'm going to do concrete, I've got to come up with concrete that is cheap. So the solutions must be designed to reflect the realities of the local environment. Then, I then ask myself, and I'm going to round up here. So what are the key trigger points I think we need to factor in as we begin to talk about scale? Reverend Chima is going to be taking the next panel, and he's going to be talking about collaboration. The fact of the matter is that we're all small players. I said this to my brother, the MD of UPDC, before this meeting. I said, all of us, when you take your entire balance sheet and dollarize it, you realize you're a small player. All of us. Yet, we're sitting on a massive market. The Nigerian home market is probably the largest untapped frontier anywhere in the world. It is. It is easily a $20 billion market opportunity. Real market opportunity. But then, how do we unlock it? The first thing we've got to do is we've got to find ways to increase collaboration. I can't do it. None of you can do it alone. Lafarge certainly can't do it alone. We've got to come up with increased collaboration. We've got to put aside our limited focus on our small balance sheets and begin to understand that the only way we can build a real industry is we've got to come together, deploy our collective strengths and capacities, and make it happen. That's the first thing. The second thing is we've got to, once we have that collaboration, we've got to get fiscal concessions. There is no way you can invest in technology without some form of concession. And when we're going to revolutionize the telecom sector, government did that. They gave huge concessions to them. There's no reason why we're not getting concessions. We don't need government money. What we need are fiscal concessions that make it possible for us to invest for the long term. I find it ridiculous that EchoStone applied for pioneering status and were denied. It is ridiculous. Because they're coming into Nigeria to come and resolve a problem, and they're putting in technology, and there's no reason why they cannot get pioneering status and concessions, and those are the kind of things we need to begin to push with government. Then the third thing is we've got to find ways of unlocking long-term capital. Once we do collaboration and we work across the various sectors and everybody brings in their core strengths, we're able to unlock long-term capital, because to unlock this opportunity will require a whole lot more resources than any of us can individually mobilize. Of course, the next thing then is market segmentation. I'm going to round up where I started from. There's no use me printing nice bungalows that are 20 square foot if the people that are going to buy them do not want them. And there's no need me building one-bed apartments, no matter how nice they are, if the people that I'm trying to sell do not want them. We've got to do a proper market segmentation and devise solutions that ensure that whatever technology we're deploying is acceptable to the market. Thank you very much.
Thank you, Mr. Dusholu. Our next speaker is, this time is a lady, Engineer Olajumoke Adegunle, Head of Motor Operations at Lafarge.
Good morning, esteemed guests. I'll ask you to permit me to stand on existing protocol. So, Mr. Jide has raised a lot of questions, and I'm sure they'll get answered at the end. But what I want to do is lend my voice to the 3D printing technology to explain it a little bit more for those of us that may still be trying to understand exactly how it works. So what we've seen, and what has been explained very well by Prof. Brando and also by Benga Onimo, is that we've had a lot of innovation in the world, across the world. And what we're trying to do is bring it into Nigeria. And it is possible. It may take us time. Yes, there will be challenges, power, etc., but it's not going to stop us from trying and seeing how we can tailor to our local market. So 3D printing, as Prof said, is usually referred to as additive manufacturing, because you just go over and you try to grow it from there. How does it really work? So basically what we have today are architectural drawings in 2D. And we take it to site and we translate that on site by taking measurements. And already today, we have computer-aided design for our drawings. But from all those collaborators that Prof. Brando showed on his slides, there is a different degree to computer-aided design to allow 3D printing. So these computer-aided designs are translated by a software and communicated to a robot. Basically, it's a robot. If I take us back to our printer that we're used to, 2D printer, we have a cartridge that has ink in it. When the ink is done, you can't print, you buy a new cartridge. The ink in that cartridge is what you use in printing, which is your mortar or your concrete. So many of us here know enough about concrete. Concrete is cement, sand, gravel as we call it, water, and sometimes you put chemicals to achieve what you want to achieve. While mortar does not have the big stones, the gravel, the aggregates. So, of course, we can imagine these mortar and concrete is not the typical one we mix on site, which is why a Lafarge Innovation Center and similar companies are involved. They are specially mixed to allow you get the kind of flow you need to get through a robotic arm. So in the video, we saw something moving back and forth. This will be a real-life cartridge for printing a home. So computer-aided design translated and transmitted to a robot, and the robot knows the design you're trying to achieve and goes back and forth, laying your mortar or concrete to achieve your wall, and it goes back and forth while lifting itself higher and higher till you get your wall. That is what we're talking about to achieve this 3D printing. So all these different factors make it possible. First, your computer-aided design, your software translating it, your robots, and we saw there are robot manufacturers, your mortar or concrete mix, which Lafarge is doing, and of course, your location, where you need to make this happen, and all the workmen and skills that are related to that. So, as a group, we've spent a lot of time on this because of our expertise. We've been over a century long in making cement across the world. We've spent decades gaining concrete expertise on concrete technologies. Those who know us know that whatever concrete you need, you come to us, we can do it. We have that expertise. And more recently, in Nigeria especially, we've started to do mortar. So what we're trying to do as a company is take us in Nigeria from the traditional way of doing construction. And we've been doing this progressively in Lafarge for the 60 years we've been present in this market. Take us from site mix to something that is more modern, which is pre-mix. We've done that in ready-mix concrete. We're present in Lagos, Abuja, Port Harcourt, and any special site we are asked to be dedicated to a project, we do that. And presently, we're doing that for mortar. And we started a tile adhesive where we've mixed it for you. As a customer, you just buy, add water, and do your tiling on site. We train tilers on how to apply for those who do not know how to apply. This has been a constant trend in Lafarge, innovation. And we sell that product across the country, and we want to do more. We want to have plasters, we want to have screeds, and all this will prepare us for something like 3D technology, because eventually we will produce that ink in this country, and we will print those houses in this country. Thank you. So this is our vision, this is what we've been working on, and this is where we are now with 3D printing. So when we come here with these presentations, please know it may not be ready right now, it may take us time, but for us the vision is to achieve that and to make it a reality in Nigeria as it is already in other parts of the world. Thank you very much.
Thank you, Engineer Jumoke. Next speaker is also from Lafarge, Engineer Femi Yusuf. He's the head of Product, Technical, and Innovation.
Broken the protocol. I have to find it. Good morning. Good morning, ladies and gentlemen. I would like to also stand on existing protocol. Thank you so much for having us here today. I think the discussion this morning is actually quite apt and very important because for several years, other industries have progressed substantially in the use of new materials, technology, and the general way of doing things. So the question has always been thrown at the built industry to say, what do we have? And it's sometimes a little bit worrying considering the fact that we have a lot of research going on, but the gap has always been to move from the lab to the field and also to scale and commercialize. So I will take more about what we have and try to go as quickly as possible into how we can adapt this to what we have today. So there will be 3D printing, reuse of materials, formwork, cement design for specific components, composite materials, mortar, and precast tiles. And interestingly, some of these have already been done, and they are working. So when you look at concrete, which we produce in Lafarge Africa, there is a need for more adoption of this, so that because that will ensure you have better quality control, quality assurance, and it's going to have an impact on reduction of building collapse. What you're having on site, on most construction sites these days, is concrete mixed with various ratios, and the impact of water. At the end of the day, the quality of concrete is not good. And when a slab is designed for a C20 concrete, it's mixed on site. What is actually a C12, the reinforcement you have placed works with a C20 concrete, so you're already having a problem. And then the durability is closely linked to the strength or the characteristic strength of concrete. So that's why we're beginning to see very quickly houses that were built in the 60s and early 70s are still standing, while you have houses that are built in 80s and late 80s are already showing very serious signs of weakness, and some of them are coming down. So we have to look into that very, very seriously. There is a debate about the use of formwork. I would like to sound a note of warning that we should not totally discard this. I think we're getting to a stage whereby a lot of these novel technologies will become like solutions that you can adapt depending on the project you are going to embark on. Still formwork, we could find out that if you're handling a project where the number of houses may be between 10 and 20 or 50, it become very useful. But beyond that, maybe it's a bit of a struggle. So I will still like us to look at this technology. We've used it, we've applied it, it works. And all technologies have challenges. If you don't have the challenge, you don't innovate, you don't improve, and it doesn't get better. And if you listen to a lot of the very good innovators, they always advise that you should not wait until you get it right. Once you have a concept and there's an aspect of it that is working, you move. You use the agile method, so once you have a deliverable that you can push out, you push it out. You may be in your lab and someone outside will be able to advise you on something that works, and then it gets better. So now there's another area where it's interesting. We seem to already have the solution, but interestingly, we've not thought about it. We have specific types of cement, and it's sort of general. But if we ask ourselves, when you break a building into its specific components, you'll be shocked to know that there are components that just require a type of cement, which Lafarge is blazing the trail now by bringing out mortar. And with that, your application is faster, and you have cost competitiveness. So that's an area that will help us. The other is composite materials. We do a lot of traditional work. You do your concrete or it's steel. But composite materials bring the power of using the strength of one material in another, and then you reduce member sizes, and you may be able to go a lot taller. And it's not as complicated as we think. You take a ribbed slab, for example. In a ribbed slab, you can achieve much wider spans. But what it's doing is that it's reducing the traditional void of your slab, so your typical thickness of beams of 230 by 450 may not be necessary. So you have reduced material, you have reduced, you also have some construction speed there, depending on how you look at it. So these are things that are already available. So what we then need to do is apply it more. I as a construction professional, I do as much of it as possible, so I'm a small advocate of new technology and application, but I believe we need to talk about this more. We need to apply more of this on larger projects, and like I said, Lafarge keeps blazing the trail. And then you have one other material that is very interesting, used a lot in Lagos, that's the precast tiles. When it first came in, there was a lot of skepticism, and what I like about the history of these precast tiles is that it's following the same trend and pattern like the new technology. So when it first came on board, people were like, let it just be used in a typical compound. It should not be used on roads because we are not sure it will work. And before you knew it, it was used on estate roads. Before you knew it, it was used on state roads that are carrying 40-tonner, 50-tonner trucks. Thank you, sir. I will round up in 2 minutes because I still have to touch on that 3D a little bit. So it's important that we open up to this new technology. Now, for 3D printing, my position and my view is that we need to move into the manufacturing circle, like cars, like phones, and where the construction has to move into that. Whatever technology we have now that will allow us to move into that, we'll have to collaborate, the research, with the industry, designers, and move that technology as fast as possible. What's beautiful about this is that it has been used to build all the typical kinds of buildings that we need. So the next phase should be, okay, if we are going to scale this up, what are the challenges and how can we resolve those challenges? Thank you very much. Thank you for taking that.
Thank you, Engineer. Before I call on the next speaker, which will be Mr. Dangiwa, Architect Dangiwa, I'd like to just quickly take you back. 5 speakers have spoken, so let me just refresh your mind. I laid out 4 criteria for the building of the future, whether it's infrastructure, if it's houses, and let's see to what extent these have been covered. I heard from Engineer Nimowu that the materials are eco-friendly, the green buildings. I heard about material quality being improved. I heard about recycling of the waste, flexible and scalable. I heard about other aspects of the materials that improve upon the current way that we're using materials, and of course improve on the waste. Prof. Okolo, in describing 3D printing as additive manufacturing, went through other features of it, including the speed that it brings, the impact on labor, the eco-friendliness, the safety on site. Remember that, safety on site, we often forget these things. He also indicated that it would have impact on materials and labor, as much as reducing the costs by as much as 50%. In terms of the future, the transformation that would take place would result in what we can find in a built environment where we have this building information management, which is completely computer-driven and allowing you to really bring down the number of people on site. Not always a good thing in an environment like ours, but we can find other ways and retrain people to be able to do the new ways of doing things. It reminds me of an old adage we used to call WYSIWYG, what you see is what you get. This time you can actually see from the drawings to the delivery of the buildings being the same. Can I say also, when Octo 5 came to speak, Jide really brought home the real dimension of the requirements and the demand. 45% demand is for lower housing. That is every demand in the sector. Houses below 10,000, 40 houses below 15,000. I'm talking dollars now. When you put those together, that's 85% of the market. The rest is where everyone is focusing, 15%. We need to retune our minds to focus where we ought to. He spoke about urbanization, and hopefully sometime tomorrow we'll be able to bring some more light to that. He spoke about the problems of power. RE, renewable energies, might help us deliver on power even in remote locations. And there's also some BEEC, Nigeria National Building Energy Efficiency Codes, which I would refer to at some other point in time. We have other local solutions. We spoke about the importance of collaboration, of concessions from the fiscal perspective. He also spoke about the need to be long-term. We are always very myopic in our thinking. The Chinese, I tend to make this expression a lot, the Chinese think in terms of 200-year horizon when they're planning. And when they're implementing, they reduce it to a 100-year horizon, and they keep rolling it forward. So if we are to compete in the world of tomorrow, we need to extend our horizon in everything that we do. Jumoke spoke about the specialist materials, how CAD and software and robots are now playing a part in, and how they're moving to the next phase of concrete mixing and pre-mixing to drive the speed that industry needs. The last engineer that just spoke, Engineer Yusuf, spoke about composite materials, and he spoke about formwork while raising a question mark about it, but we need to adapt the technology to our environment. So that was just to give you a perspective of what has been covered in the session to date. At the moment, I'm going to invite Architect Dangiwa to speak on the financial, I believe you're speaking on the financial aspects, aren't you? Yeah, and delivery of housing. So, Architect Dangiwa, MD, CEO of Federal Mortgage Bank of Nigeria. Yeah.
Thank you very much. I really enjoyed the last presentation. It was very interesting for us in affordable housing delivery to Nigerians. I wish Mr. Festus will invite them for the next housing show to do their stand here with the 3D presentation. That will be good for us to see, honestly. So I was to make a presentation yesterday quite well on housing finance in post-COVID-19 era, lessons and opportunities for emerging markets. I had to travel yesterday to come back yesterday, but I couldn't because we had a meeting with the governor of Kano State till 2 a.m. for their return to National Housing Fund. And yesterday morning, the weather couldn't allow any flights to fly till late night. I'm sorry for that. Thank you very much. I think if I can, am I supposed to take that same paper as of yesterday?
I think it's on this.
Okay, thank you.
Already, yes.
Right. Thank you very much. The paper, quite well, is on the housing finance post-COVID-19, the lessons and opportunities for the emerging markets. What you need to know is that the paper will capture the COVID-19 pandemic where we are currently, the global perspective and the Nigerian perspective, the responses to the COVID-19 pandemic and the impact on housing, then the lessons from the COVID-19 pandemic for emerging economies, and the conclusion, of course. So my first, that one is we'll have to look at the global, because since it emerged in December 2019, the COVID-19 pandemic has been a dramatic change in life, as we know, both in the economics and health system. But we have to know that the economies and health system are seeing the signs of recovery with the vaccinations in the first half of the 2021. The efforts are open now for the upcoming economies to start life under the new normal. However, as you quite well know that the concerns are rising due to the third wave of the COVID-19, which has driven by the virulent Delta variant of the COVID-19, which we learned is more devastating. But the pertinent questions we need to ask, being asked now, are that when will there be an end to this pandemic? How effective will the vaccinations be against the future strains and variants? I've had my 2 shots on the vaccine, but someone was telling me I have to be careful with the third variant because it might be more devastating. It may not even recognize the vaccine. So we have to keep praying. And how soon will you see some of the semblance of stability of the global economy, and what will be the long-term impact of COVID-19 on health and the economies of the nations? So for Nigeria, since we have looked at the global, for Nigeria, thankfully the health impact relatively mild in sub-Saharan Africa and Nigeria as a whole, both locally in Nigeria. I think we are one of the luckiest nations or the luckiest race in the world. However, the socio-economic impact has seen a devastating, particularly for Nigeria, because we suffered twin shocks. Because apart from the shocks of the COVID-19, there's a fall in the national revenues arising from the Russian-Saudi oil war, price war in the 2020. So Nigerian economy slipped back into recession, and by mid-2020, following the slight recovery from the 2016 financial crisis. However, we are very optimistic economically because the outlook for 2022, after the rebound of the last quarter of 2020, you will see some semblance. From the graph, you can see that the GDP has dived down after 2020, then it started rising. So also the real GDP also rose, and then that of the CPI, which is a consumer protection index, and the budget balance has also been rising, with the current account, which is also rising to that level. The policy response, if you look at the responses of the COVID-19 pandemic and the impact on housing, the first one is the policy response to COVID-19. Apart from the lockdowns and restrictions in movements, government across the globe has taken fiscal monetary policies to address the economic fallout of the pandemic. In Nigeria in particular, the combination of government and CBN initiatives are that of the fiscal measures and then the monetary measures. From the fiscal measures, there is a revision of the budgetary targets, including the 550 billion naira COVID-19 intervention fund. All agencies and ministries were asked during the pandemic to reduce their budget downwards by almost 30%. There's also 150 billion naira support for subnational entities. There's a conditional cash transfers to 3.6 million households through social register that was taking place at that time. There's a business wage support where some small businesses were supported in order to pay their wages for their own staff who are unable to move out during the pandemic. And we also have the public works programs. For the monetary measures, there is a forbearance on the interventions, loans by reduction of interest rates from 9% to 5%. There's also reduction of monetary and policy rates. There's a proposed injection of 3.6 trillion into the banking sector to support the health with 100 billion naira, manufacturing 1.2 trillion, or 2 trillion, and the real estate of 1.5 trillion. There's a creation of 50 billion naira target facility and, of course, the currency devaluation. Another response is the actions on the housing sector, which is more particular to this, is there were quick interventions for rental and mortgage composites of the housing sector by most national governments. Particularly we in the mortgage sector, we gave our own concessions to those who could not pay their own mortgages. Concessions were given to them if there are enough reasons to know that. On the real markets, we have suspended evictions were also suspended because you cannot evict somebody during the COVID-19 so you cannot go out to fend for himself. So at that time, there is the suspensions of evictions, extended rental contracts, there is rent freezes, and even rent subsidies were given at that time. The mortgage debt markets were also not affected in the housing sector, which is the mortgage forbearance, the foreclosure suspension, because the time you suspend evictions, you have to do that as well. Then the mortgage repayment support and tax difference. Other impact which is worth noting is the impact of response and actions of house prices. Because house prices appreciate in most developed countries in 2021 currently. In US up to 13%, in Canada 7%, and kept on going, Australia 6%, and year on 23% in New Zealand and 9.5% in UK. But caution must be taken as exercise to avoid the reliefs and the interventions resulting in long-term market distortions, because housing price bubbles as a result of interest rate mitigations for tax exemptions and withdrawal of rental housing. From this one, the graph, you can see that the impact is there, then the relief measures are there, and the possible long-term distortions are all enumerated, as I said earlier. Then if you go to the real response of the impact, we need to go to the lessons learned, since we have discussed about the impact, the response. The lessons are that affordability for demand side housing finance will become more critical in the face of falling or outright loss of income going forward. And then there's also the housing needs are changing, the real estate landscape, and need timely response. Because homes have now turned into, they are no longer accommodation living spaces, but they are transforming into workplaces as well as work goes remotely currently during that time. The second group of users who's in the age bracket of 25 to 35 years will drive the new dynamics of housing needs, either as renters or home buyers. Because those age brackets, they have more different demands currently. Within the Nigerian market, real estate developers already are witnessing preferential of smaller or more compact and functional spaces, like studio houses and two-bedroom flats. Existing large properties are being remodeled to offer shared or temporary accommodation, especially in the upscale areas, to make rising property prices more affordable. The other lesson is that technology and innovation, which you all know, with the technology of this 3D during the COVID-19, it will make a lot of impact at that. For FMBN, as we quite well know that Federal Mortgage Bank of Nigeria, we have embarked on adoption of core banking solutions and that technology. And during the economic, there was a National Economic Sustainability Program by the federal government of Nigeria at that time, which appointed the vice president to be the chairman of that. Institutions were encouraged to make an impact, especially create jobs and ensure that they reduce poverty and they reduce the impact of the COVID-19 pandemic at that time. FMBM was not left out to the production of 5,000 housing units. We have to fund 5,000 housing units with 40 billion naira in order to reduce the effect of COVID. The contract for this has been awarded. Most developers have already on site for these ones. So in the conclusion aspect of it, you'll find that the impact of COVID-19 pandemic has been devastating to health and economic life of countries, including the emerging economies which face additional economic challenges arising from poor fundamentals. But after a general lull, the real estate sector is experiencing a rise or is experiencing an uptick. And the more preferred destination of investments, shunning the more volatile money and quality of market in most economies, as evidenced in the rising property prices. This positive trend, however, implies more pressure on achieving affordability and accessibility for the medium and low income market as macroeconomic indicators turn negative. The need for government interventions to stabilize economics and housing markets remain paramount in the near future, despite the risk of rising price bubbles. Despite these, opportunities exist for growing housing market in emerging economies by public and private sector initiatives that key into emerging trends and preferences and integrating innovative technologies and practices. That's why I found this presentation by the last presenters on 3D technology very interesting. The other questions, which I'm sure people will ask a lot of questions when it comes to that. How affordable are they and how could they be deployed to the low-income segment of the market of the housing? Thank you very much for the opportunity. Thank you very much.
Thank you, Engineer Architect Dangiwa. From your presentation, I picked up a couple of things. I see the changing needs for housing and the changing dynamics of and requirements of the new class of homeowners going forward for the future. And I see in it, from a financing perspective, the need for new risks, new models of financing, and really new ways of looking at the investors, of looking at the buyers, of looking at the developers, of looking at the market. We no longer have the market of yesterday. The market of the future has completely different dynamics. Octo 5, Jide in his presentation, drew attention to that. Now I open up for a few minutes to take questions for the presenters. Please keep it short. We'd rather you ask a question than make a comment. Yeah.
So please, if you have a question, can you signify by raising your hand?
Yes, there's a gentleman on that end.
Thank you. Good morning, ladies and gentlemen. My name is Nasir Ibrahim from Black Orchard. An interesting presentation that will have an impact on the construction industry. But I'm wondering, similar to the presentation of Architect Giwa regarding the impact of COVID on the global economy. Usually governments, if they want to stimulate the economy, they go into construction worldwide. Everybody will agree with that. I'm wondering if the use of 3D printing will have an effect on creating jobs. When you go with robots and things like that, they have the tendency to eliminate the numerous number of people that are working in the construction industry. So I don't know if Lafarge have thought of the impact of going with technology to the detriment of the labor that is being generated by the construction industry. Thank you.
We can take another question before I pass it over. Anyone else? Okay, I'd like Professor Okolo to first of all respond to that question from the perspective of the...
Sorry, Mr. Chairman. Someone has a question.
Okay, please, go ahead.
Engineer F.O. Akbonowo is my name, from Asaba, Ministry of Housing. From the presentation of this 3D construction method, I discovered that we're going to go on high-rise buildings. What provision for stability of the building? Because in our conventional constructions, there is this provision for reinforcement. We talk about reinforcement area. So I want to see, the question is what provision is to be made or to be included in order for it to be stable, such structures. Because from the engineer who presented first, and the first analogy, I saw the additive remodeling, everything to the point of the roofing, even for the story structure. So what aspect or what type of thing are they thinking of, or technology that can strengthen the building just the way the reinforcement does? Thank you.
Thank you. Maybe we can take one more? One more? Okay, if not, sorry, there's a gentleman here. Are the ladies all happy with their presentation? I'd like to see a lady raise question.
Good afternoon, everyone. My name is Khalid Lawal from Greenland Concepts. With respect to the 3D innovation, we all know the emerging market is going towards that path, but the main question will be the affordability. What is the comparison in terms of costs? We have the block, the mortar components for the traditional building. What is the comparison in terms of cost to the 3D printing? Thank you.
Right. Okay, so Professor, as you answer the first question, I'd like you to respond specifically to the aspect you said 3 people on site can deliver on the construction. So what's the impact, adverse impact on the jobs market?
Yeah, thank you very much for the questions. In terms of the adoption of this technology within the labor market, factors, jobs will be lost, but new jobs will be created as well. In my presentation, I already talked about the fact that the construction sector is a muscle-driven sector, the way we see it today. And you cannot keep competing on muscles. At some point, brain power takes over, and we need to start getting our people to the point where brain power takes over. Brain power generates more income. This is a fact. So the concept of, jobs are lost, jobs are gained as well. The marketability of our labor force increases as well. It has to do with retraining the labor population we have. I just give an example. In Germany, one of the things that happened as a result of COVID was that pilots lost their jobs. We have about almost over 500 million pilots existing in Germany. Out of that number, more than half of them have lost their jobs. And part of the things they've done is to go to look for new employment possibilities. Pilots are good managers. Some of them are being retrained to do new things. It is also the same for the construction industry. Once a new technology comes, certain jobs disappear, new jobs come up. Today, we don't have secretaries as we used to know them 30 years ago, because the director, the managers, they all use their laptops. They use their phones to do new things. The secretary, as we know it, is lost, basically, or the typist, as we know it, is lost. The evolution of our labor environment has to be appreciated. This is all I can say about this.
Prof, I can also think of young people being able to develop the software and the programs that would drive this industry going forward. So it's not all on the negative side. Yeah. Thank you. Anyone else from, yeah, okay, please, engineer.
Yeah, I mean, I think I'm very much aligned to what the prof said. We definitely, there'll be new opportunities, and like you said, in the software and engineering part. But again, to be honest, we also need to also prioritize, take things one at a time, deliver the housing, let people have shelter, very important, and the other things will follow. And I know the government is doing a lot also in terms of empowering people in other areas to create sustainable jobs. So, yeah.
All right, thank you. Okay, to the second question. Mr. Duffield, do you want to say something?
The only thing I have to add to that is, and I actually disagree about jobs being lost. So the prof is right. We're a muscle-driven society right now. We need to become a skill-driven industry. We have huge deficits when it comes to finishing specialties. We don't have, most of our masons can become master tilers, but they don't need to scale up right now because it's easy to just be laying blocks. The minute we begin to go with technology, all the skill levels have to go up. Once the skill level goes up, the earning capacity also increases. So I believe that in the end, it's a win-win, not a loss-win.
Thank you. Second question.
Yeah, so I think the second question asked Engineer Yusuf, that was talking about...
Yeah, the tensile strength
yes.
and the concrete durability.
Yeah, for the second question, it was actually talking about stability of the building as you go up. So, and stability for anything with a spine is a function of lateral wind load or where you have earthquake issues. But we're very lucky. Nigeria has a very low seismicity band, even though there's a lot of serious look at that because we're beginning to see light tremors here and there. But for typical areas where you're looking at wind loading, what you're going to have for your G+1 is that the mortar will have areas that will also be reinforced to take your lateral wind loading. Now, if you're going to go higher than that, you now then have to think of your typical shell wall that is designed to resist lateral forces. So that will be embedded within your building. But what is interesting about what we are seeing is that your printer is a typical steel frame, and then you have the printer head that is printing the walls. Now, if you're going to go higher, you then need your steel frame to be taller before you print the wall for the next floor. But then you have to put, stability is a key component of any structural frame. So what you do is that you put in your elements that will resist lateral forces before you do your next floor. So that will be your construction sequence. But when you compare this with the traditional form of construction, you are still going to be faster. And like what I was saying when I was talking about the use of composite materials, there's a lot of power in 3D printing that we have not even deployed yet. Because right now, we're still looking at, let us even get things right. For example, the walls, what we are seeing, you are talking of a 20 megapascal wall. So right now, to be safe, what we are doing is using, even for the ground floor buildings, we're still using very light steel members. We're not loading the wall as it is. So we're still using very light steel members just to check to be sure that everything is fine. The next phase is you load that wall. Once we are happy with the trial, with the modeling in the lab and on the computer, when you get to your G+1, you are now be talking about precast floor slabs. So you're going to have a faster speed of construction, and you're going to have a lot of efficiencies. So the question is fantastic. It's actually apt, and it's going to incorporate your standard procedure for structural design, but it's going to allow you the flexibility of looking at composite material, of also reducing the cost of construction. Thank you.
Thank you, Engineer Yusuf. And to the third question, any other panelists? We're wrapping up. Can you just repeat your third question again, please? The gentleman that right there. Okay, affordability. Yeah, the cost. So I think, yeah.
Okay, thanks. I mean, interesting, you know. Again, if I bring it down home to Africa, you know, we're just starting this, and we're still developing and learning as we go. But if you recall what I showed you in the example we've done in Malawi, In terms of materials, efficiency, we're talking 60% savings. And, we're saying, if you look at the traditional way of building, really that's where materials, labor, those are huge cost drivers. And technology actually helps you to bring this down. And I think this was actually also reinforced by the prof when he mentioned also. So definitely, I can't put a number to it yet, but there's definitely some good savings that will come. Okay, Femi.
Just on the savings as well, there's an aspect of the savings. I was having a chat with Benga, I think, over the weekend, that when we get into the actual construction, this bit about the time you gain and the reduction in waste of material, I won't be surprised if we already have a few people doing research on it. But right now, we cannot put numbers to it, but I can guarantee you there's a lot of savings there, which over time, data will show us what's actually being saved. And this hits the bottom line of a typical contractor. So I wouldn't like us to look at savings just from the savings we are making on the frame, but let's look at the overall holistic picture and the impact it is making. Yeah.
The fact that we're able to scale up is also going to add to the savings. Prof, do you have some more remarks?
Yeah, I just want to say something about the structural strength of the printed houses. The good thing is that all the work that is done physically is first of all done in simulation. And oftentimes the agreement between your simulation result and what actually comes out is really, really good. So we have a case where any structure that is 3D printed is rigorously analyzed using computer tools or computational tools, and the data comes out well. Today, with 3D printing, we cannot go beyond the 4th floor today, anywhere. We cannot go beyond the 4th floor. And the simulation work that makes that possible is sound and solid. If it could be done in Germany, where we have very strict building codes, then it's possible. The next one I just wanted to say is on the cost savings part of it. In terms of cost savings, if you think about the waste we have in our construction sites today, it is horrendous. You have a tipper of blocks come in, about 10% of them are destroyed. You don't have that in 3D printing. Thank you.
Yes, thank you very much. And just to also add, if I look at it also from the financial point of view, we've been talking of, funding for this. So imagine you pick up facility to develop. Once you can do that faster, you can turn it over faster, you sell, and at the end of the day, your overall cost of funding is reduced. So I think, like Femi mentioned, it's holistic. There's so many areas, we can bring it all together.
Yeah, I'd like to thank our presenters for their very engaging session. And I'd like to also let you know that tomorrow there is a session on prop tech. So that's sort of beginning to push the frontiers of what we can do in this sector. So please, the first session tomorrow, I hope it will be the first session, but one of the sessions tomorrow will be covering that. So thank you very much, and I hand over now to the organizers. I think the custom is to have a group photograph. So if the photographers are close by, just 30 seconds to have a group photograph, quickly.